All right, in this lecture we're going to talk about finding the greatest common factor, the GCF for short. Basically, the greatest common factor is the largest number and variable that will divide into all of our terms. So one way to do that until you get good at it is to basically prime factor all of our terms. So if we look at these three individual terms, there's no pluses or minuses, they're just kind of floating terms here. Like if I wanted to prime factor them, that means I'm going to write them as a series of multiplications until basically all my numbers are prime. So that would be 14 is 2 times 7, right? And then I can write the x cubed. It literally means x times x times x, 3 x's, right? So that's the prime factorization of 14x cubed. So 21x cubed would be 7 times 3, and then I've got 2 x's. Okay, and then my 35x to the fourth, and 7 and 3 and 2 and 7 are all prime numbers. 2 is the only even prime number because that's the first one. And so 35x to the fourth can be written as 7 times 5, both prime numbers, times 4 different x's if I write them out long way. So I can find my greatest common factor as finding the number that's common to all. So if I start over here, like 2 is only in the 14. There's no 2's in the other. And then I look at the 7. Yep, there's a 7 here. There's a 7 here. And there's a 7 here. So it's in all three. So my greatest common factor here includes a 7. Okay, so then also each one of them has, I'll start with the first x. They all have that x in common. And then I can do one more. So there we go. But I can't do a third one because this one has an x, but this one is out of x's, and this one has an x. So it has to be in all three. So since this one ran out, basically I just have x, and I'll write it together again as x squared. So my greatest common factor is 7x squared. Factoring is really important to us because we're going to be dealing with a lot of quadratics and polynomials, and part of the technique of solving them requires factoring. So this is one technique to factor, and that is to factor out the greatest common factor. So we found that now I've just combined these three terms with pluses and minus between them, so it's like one big polynomial is what we call it here. And I already looked at these three terms, and I know the greatest common factor is 7x squared. So when I factor it out, I write that 7x squared that's common to both out front, and then I'm going to open my parentheses. Now something that's really important here is to remember that if there are 1, 2, 3 terms in here, there should be 3 terms in here. So basically I'm going to go term by term and decide this times what will give me the first term. So that's the first thing I want to do. So 7x squared times what will give me 14x cubed? Well, I already have the 7, so 7 times 2 would give me the 14, so there's a 2 here. And then I have an x squared here, my x cubed at the end, right? So I need one more x, so this will be 2x. All right, so then I'm going to move to the next thing. So I'm going to get negative 21 out of this. So what would I multiply? So I'm going to put my sign in front. So 7 times negative 3 would give me 21x squared. So I have minus 3. So instead of putting plus minus, I just put the minus 3 in front, so subtraction. So 7 times negative 3 would give me negative 21. Right? Then I already have the x squared. So no x is needed. Okay? So then I have plus. So 7 times, because 7, this is also positive and this is positive, so this will also be a plus. So 7 times 5 would give me 35, so that's what goes here. And then I have 2 x's here. This one requires 4, so I need 2 more in the form of x squared. Okay? Now in the next section, in the next lecture, we're going to learn how to factor something that looks like this down further, because this is what we call a quadratic. Usually we see them written with the x squared first. So we could write this in just a different order with decreasing x's as 5x squared minus 2x minus 3. Now not all quadratics factor, but the ones that do, we can sometimes break this x squared thing down some more. Okay? So So now this time I've still got these same terms, right? So the leading coefficient is the number in front of the biggest power of x. So I have them written this time in decreasing order. So I've got x to the fourth, x cubed, and x squared here. And so usually I factor out a positive number here, right? I factored out a positive 7, even though I had a minus in there. I could have technically factored out as a negative 7 and gotten something a little bit different here, and it would have worked. But typically we don't factor out a negative power or a negative number, I should say, unless the leading coefficient is negative, which means the number in front of the biggest power of x, which is negative 35 in this case. Now my greatest common factor is still 7x squared, but because the leading coefficient is negative, we're going to factor out negative 7x squared this time. Okay, so this time I'll just use a bracket. All right, so I have negative 7x squared. The first thing I need is the number. So negative 7 times positive 5 will give me 35x to the fourth. Okay, so this will be a positive 5 here because a negative times a positive gives me a negative. All right, so again I have x squared here. I need x to the fourth, so I'm missing 2 of them. So this is 5x squared. Okay, so then again here, so negative 7, my next term that I'm dealing with is this. So negative 7 times negative 2 will give me positive 14. So this next one is negative 2, and then this is x cubed. I need one more x because I factored out 7x squared, so I need one more, so that's that. All right, and then my last one, so negative 7 times positive 3 will give me a negative, so it's just plus, and then 3, my x squareds already match, and so that's factored. Okay, so we typically only factor out a negative number when our leading coefficient is negative. That's just standard in mathematics. Okay? All right, and that is mostly because, just to throw in this, when we're factoring quadratics, like this x squared term, it's a lot easier to factor that with a positive leading coefficient. Okay, so we have something a little bit different, right? Different numbers this time. And so first we want to factor out the greatest common factor. Okay, so let's see. Let's come over here. So 24y cubed could be written as 6 times 4, right? And then y times y times y. I could break that down a little further into 2 times 3 is 6, and then 2 times 2 is 4. So completely broken down, I could write it like this. 2 times 3, I could write it as 2 cubed times 3. It doesn't matter. I'm just breaking it down into simple multiplication. All right, so then I have 18y squared. I'm going to ignore the minus right now. I'm just trying to find the greatest common factor. So if I break this one down, I could write this as, and it doesn't matter, like I could have started with 8 times 3. When I get to here, I should still have the same thing. So there's no stress as to what numbers, as long as they multiply together to give me 18. So I'm going to choose 9 times 2 this time, and then I'll write the y squared as yy. The 9 can be still broken down into 3 times 3 times 2, and then yy. And then my 30y, okay, is, so I'm going to choose 5 times 6 this time, and then just one y. The 5 is prime, so I'll leave it. And then 6 can be broken into 2 times 3. Right? You don't have to do this if you can spot it, right? But if you are having trouble spotting it, this is always an option. Okay, so they all have y's, so I'm going to circle the y is common. So here's the final ones. Let's underline those so we don't get them confused. So they all have one common y. Now there's only one y here, so that's the only thing that's common to all three as far as y's go. Okay, so I also see a 2, and a 2. And then they all have 1 3 as well. Okay, so then there's a 3, there's a 3, and there's a 3. Now this one has a 5. No other ones have a 5. This one has extra 2's. This one does not. So I think we're good here. We've got all the ones that match. So basically I have 2 times 3 times y, which we will call 6y, as my greatest common factor. So that's what's going to go out here, 6y. All right, so my first one, I'm always trying to do this first. So this has 1, 2, 3 terms in it. So I'm going to have 1, 2, 3 terms in here. Okay, so 6 times 4 will give me 24, so the 4 goes here. I have 1y, I need 3, so a y squared goes here. All right, so 6 times negative 3 will give me 18, so this is a minus 3. And then I have 1y, I need 2, so I need 1 more. All right, so 6 times negative 5 will give me 30, so this is a minus 5, and the y's already match, so I'm closing my parentheses. Now again, in the next lecture, we'll learn how to factor these, right? Maybe down a little further, but for right now, we're just factoring out the greatest common factor. Okay, so now that one's finished as far as I know right now. So until we learn how to factor a quadratic, we can look at this one a little closer, but this is the greatest common factor factored out. All right, so this time I have 3x squared plus 7x squared plus 2x. Okay, so I'm looking at all of these. All three of these are prime numbers, so I'm not going to go to the trouble of writing them over here. They don't have any factors in common, right? Because 3, 7, and 2 are all prime. And there's no point in me factoring out a 1, right? That doesn't even, I mean, we usually don't even write 1 when it's on the outside. But they do have, this has 3 x's, this has 2, and this has 1. So they do have 1 in common. So I'll factor out the x, okay? So that means I'll have a 3x squared here, because this times this will give me this. This will give me 7x, and then plus 2, and that's the greatest common factor. Okay, so let me do one more here. So what if I have 6x squared plus 4x plus 2? Okay, actually, let me raise these. Let me have x cubed here, x squared here, and 2x here. So this is 6x cubed plus 4x squared plus 2x. All right, so my greatest common factor, without going too difficult, is these are all, this is 3 times 2, this is 2 times 2, and this is 2 times 1. So my greatest common factor will have a 2 in it. Okay, then I have 1x, 2 x's, and 3 x's here. So I can only basically have the smallest one that will go into all three, right? Because this one doesn't have 2, so I can't factor out 2, and neither one of these have 3 to factor out 3. So I'm going to factor out a 2 and an x as my greatest common factor. All right, so now this is why I was stressing. This one's a little bit different. So I have 1, 2, 3 terms in here. I have to have 1, 2, 3 terms in here. Okay, there doesn't magically go to 2 because I should be able to multiply this by all 3 of these and get this back. Okay, so I have 2 times 3 will give me the 6. I have 1x, I need 3, so I need an x squared here. All right, so then 2 times positive 2 will give me positive 4, so I'm going to have a plus 2. I have 1x, I need 2. I add on an extra x here. And now here's the tricky part, right? This is a 2x already, and this is 2x. You might be tempted to close my parentheses, but if I do that, when I multiply this back, I will only get these 2 terms. So when they match exactly, right, in this case it's positive, so 2 times positive 1 will give me positive 2, and then I already have the x, so the 1 has to be there, right? If I had 6x cubed plus 4x squared minus 2x, and I factored out the 2x, this would be the same, 3x squared plus 2x, but this time this would be a minus 1. So regardless if it's positive or negative, there has to be 1 there if it matches. Otherwise, if I just had 2x times 3x squared plus 2x in my parentheses here, right, and closed them, when I multiply this back, I would get 6x cubed plus 4x squared, and it would end. How am I getting the 2x back? So this has to be there. So something I always remember is if there's 1, 2, 3 terms here, there should be 1, 2, 3 terms here. That applies to any number. If I had 8 terms here, when I factor out the greatest common factor, I should have 8 terms in my parentheses. And that concludes our lesson on the greatest common factor factoring.